Hi, I'm Rishi. I'll be explaining the experiment number three for the machine learning techniques. So, uh, first question is to read the CSV data, and it is read into a pandas data frame. So the data frame is DF. So it is the data set is iris regression.csv. This is a CSV file, and then the second question it is data cleaning. So it will handle the missing values. So missing values will be replaced with column mean. So its meaning is it ensures the data set has no not number values, NaN values, allowing correct calculations. So the third question is choose independent x and independent y variables. So we've chosen x at x, which is the independent variable as sepal length cm, and the y as width cm. Uh, uh, so that the meaning is the length is used to predict the width. And coming to the fourth question, compute regression coefficients. So b naught and b1, and the formula is given here. With the intercept is b naught and b1 slope. First, we need to find the slope. Then only we can find the intercept. The slope is we've gotten the slope as 3.4194, and I mean the intercept and the slope as minus 0.0624. So yeah, so the regression equation. So regression equation is y cap um, is equal to the first intercept plus the slope times x value. So that is done, and then sum of squared error is also calculated. That is the total square difference between between actual and predicted values. And then the seventh question, that is root mean square error. Uh, Root mean square error that we have, it is the average prediction error that is predicted. We've gotten it as 0.4291. And then on the eighth question, it is R square score. That is the equation is given here, and the meaning is like that we've gotten 0.0139. So that meaning is only 1.39% of variation in the width is explained by length. So coming to question 9, that is a regression plot or regression line, we can call it. And the output is given. So the meaning, it shows well how well the regression line fits the data. It is a scatter plot with the regression line. And 10th question, prediction. That is, uh, we've got the prediction for x and y. So x is 6 and y is 3, meaning if length is 6, then the width is 3.0449. And coming to multiple linear regression, first we read the data into the data frame. Then the data is cleaned, missing value replaced. Then third one, the variables are selected, such that width is predicted using two features here: length, sepal length and petal length. And coming to question number four, regression coefficients. Intercept is b naught and b1. Intercept is b naught, and b1 and b2 are given. We got the values, that is x1 and x2. I'm sorry, x1 and x2. That is sepal length and petal length. B naught is 1.2360. So then what's the meaning of this is length increases with the width. So petal length slightly decreases sepal width. So regression equation is that is given here: b naught plus b1 times x1 plus b2 times x2. which is given here, uh, and the SSC is also um, given here, and the root mean square error also given here. Uh, and the meaning of this SSE is prediction error is lower than simple regression. And then root mean square error, uh, average prediction is given here, and R square error, and R square score, uh, R2 score, or R2 score you can call it. It is 0.4111, so that is 41 percentage of variation is explained by the model, and it's 9. It is prediction. X1 got X1 6, X2 4, and Y 3.0539. So that the meaning is predicted sepal width is 3.0539. So logistic regression, dataset is read, pre-processing is done. Uh, uh, the species is converted to numeric labels, which allows the model to process categorical data, and then features and target are selected, that is independent variables x and dependent variables y. So features are sepal length and width, petal length, petal width. Target is species, that is dependent. uh, so and then coming to question number 4, called cost and gradient descent, that is sigmoid function. Probability values between 0 and 1, is converted into that, and meaning it converts linear output into classification probability. The formula is given in the code. Uh, then question number 5, plot the graph for iteration against cost. So I think I left. Yeah, after sigmoid function, we have weights. These are the weights here. These values determine the importance of each feature. Each feature in the sense each trait of the flower from a flower data set. And uh, accuracy is also given, that is 89.33 percentage. So like accuracy of the model is which means that correct model correctly classifies 89.33% of the samples. Before that, we have this gradient descent. I mean, not the gradient descent, but mm, yeah, yeah, gradient descent. That is 0.2736. So that lower cost indicates better model training.